Alright, in this video we're looking at exponents here. So the E is exponents, brackets exponents, division, multiplication, add, subtract. Now an exponent works like this. Let's say I had the number 5 and then I had this little thing on the side. This tiny number is called an exponent. I should have put it a little lower. Where an exponent goes, just so you know, here's the halfway point of the line, here's the bottom of the line, here's the top of the line. The exponent crosses the top of the line. You do not write 5, this reads as 5 to the power of 2, okay, 5 to the power of 2. 5 to the power of 2 does not look like this. It definitely has to be higher. It has to be higher than that top line. All right. And what this means actually, it means that this number here, there, is replicated this many times. So really that's 5, and it's in a multiplicative relationship, it means 5 times 5. It does. Some people will say, hey, look, that's 5 times 2, right? Because there's a 5 and there's a 2. Incorrect. The correct way is 5 times 5, which of course is just 25. So that's how an exponent works. And I'm just showing you that quickly so when we do BEDMAS with exponents, you're not going to be totally blown away. 3 to the power of 4, well, that is 3 replicated 4 times, and then we just can multiply that out, 81. Some people are going to say, hey, 3 times 4 is 12, and they would be incorrect, so don't be that person. Okay, so that's just a little briefing on exponents. So now we're going to do some questions with exponents in them. So here's my question. I have 6 to the power of 2 minus 3 plus 20 to the power of 2 divided by 4 minus 10 divided by 2 plus 3 to the power of 2. Also, by the way, this reads as 6 squared, 20 squared, and 3 squared. So again, we look at BEDMAS. There's no brackets, so don't worry about the B, but there is exponents. So what is this going to look like? That 2 tells us to replicate the 6 twice in a multiplicative relationship. It goes like this. It applies to that. This here applies to the 20. So the 20 gets replicated twice in a multiplicative relationship. And then over here, the 3 gets replicated twice in a multiplicative relationship. Everything else that we didn't touch comes straight down. So for example, we didn't touch the minus sign. We did not touch the 3 or the plus sign or the divide sign or that thing, that, or that, or that. Everything has to come right down where it was. Now, this stage in the game, we have no more exponents, so we can cover up the exponent. Now we're looking at division and multiplication, so that's what we're going to do next. So we start with an equal sign. There's multiplication right there. There's a 36. There's multiplication. That's 400. Oh, look at this. You know what I'm going to do? I'm going to show you how this works right now. If you ever have multiplication and division together, you just got to go left to right. So I did those, got 400, and now I'm going to do 400 divided by 4 for the next line, which is 100. Okay, that's the next line though. Okay, back to here. 10 divided by 2 is 5, and then 3 times 3 is 9. So again, bringing down everything we didn't touch. The minus sign is there, the 3 is there, and the plus is there. The minus sign is there, and the plus is there. So the next line, 36 minus 3 plus 100 minus 5 plus 9. Nice and clean. We know exactly where our signs came from. And now at this stage in the game, we can just go left to right because it's only adding and subtracting. If it's only adding and subtracting, you can go left to right. So 36 minus 3 makes 33. Then you carry everything down. 33 plus 100 makes 133. Carry everything down. 133 minus 5 is 128. And 128 plus 9 is 137. So that would be your answer right there, 137. Just like that. And, whoop, I forgot. Look, I need to have equal signs out front. That's where the equal signs go, you guys, in one straight line. You don't put them over here. That's not where they go. they go in this line over here. Keep your work orderly. And then that would be satisfactory according to the math gods. Okay. So there's an example there of order of operations with everything up to exponents. All right.